In this lesson, we're going to look again at trigonometric graphs and different variations on them. So in order to kind of have a quick look at that, we'll go back to this idea here. If we look at the keyboard here and we look at the waves it's making, that's not a very, not a lot of waves on the screen there. If I change some things, I've got more waves on the screen. More waves on the screen, and then loads of waves on the screen. So we're going to look at this kind of idea and what numbers are needed or required to make this happen. Okay, so this lesson here is really about y equals sine something x or y equals cos something x. And this can be applied to tan as well. I'm going to look more at sine and cos, but it can be applied in the sense of a tan graph. So let's firstly look at y equals sine 2x. So what's actually happening here? So if x was 30, then I suppose we could agree that 2x would equal 60, double it. So when you're doing the sine of 2x, you're really doing the sine of 60. Now the sine of 60, if you type it into your calculator, should be 0.866. Okay, so that might not tell us too much, but if we try and refer it back to the normal graph, here's the normal sine wave graph. It peaks at 90, goes up to 1, at 180 down back to 0, 270 down to -1, 360 back to 0. Now if you put in 15 to sine 2x, then that's really the sine of 30, which is a half. So this half value is actually happening at 15 instead of 30. If you've put in x is 30 to sine 2x, then you're getting the sine of 60, which is 0.866. So this 0.866 is happening at 30 as opposed to 60. And if you put in 45, then sine 2x is really the sine of 90, which is just 1. So these first three values are actually happening much earlier, 15, 30 and 45. So it's peaking much earlier than when it did in normal sine wave. So maybe you can think about what's happening there, but in order to fully understand it, we better draw the graph. Now, what you'll notice here is I've got some additional values here. I've got the 45 and 135. We'll talk about that in a second, but let's try and plot this graph. So what I'll do is I'll give you a bit of time to pause the video and try and complete it yourself. If you're not sure how to start it, then it would be the sine of 2 lots of 0. That would just be 0. This would be the sine of 60. So that would be 0.866 and so on. So I'll let you try and complete the table in your jotters and then come back. Okay, so hopefully you paused the video there. You tried to complete the table. We'll do it together now. So this is why I've put the 45 in here. It wasn't there before, but if we think of a sine of 2 times 45, that's a sine of 90. There's our 1. 60, that's sine of 120, isn't it? Because you're doubling it. Just type that into your calculator, sine of 120. This one will be the sine of 180. This one will be the sine of 240. And this one will be the sine of 270. And you just keep doubling it and so on. And I'll show you these values here. Okay, so that's what your table should look like there. Now, if we're to plot this, if I change to a pen tool, at 0, we're going to have 0. This time at 30, if you do 3 boxes again for 90, 3 boxes, 180 and so on, there should be 12 boxes along. It's harder for me because I've got no boxes, but 30, it should be 0.866, something like that. Now at 45, it's peaking out at 1. Then it's going back to 0.866, probably a bit higher than that, but there, let's say. And at 90, it's gone back to 0. And then at 120, it's going to negative 0.866, so see that's there. And then at 135, it's at -1. It's going to come back up here and then go to there. So you're getting one complete wave much earlier than the normal sine wave. It's finished at 180. Now what's going to happen after that is it's actually just going to repeat itself. Now what you'll notice here is there's no 1 or -1 here. Have a wee think about that yourself and wonder why, and I'll tell you in a second. Again, you can pause the video. Okay, if you've had a think about that, well, the peak actually happens between these two values, and that's why I included these green values here. We normally just did 30 and 60, but the peak happened at 45. So if you're trying to find out where 1 would happen, it's halfway between here. So what would that be? Well, the difference is 30, so 15 in from either side, so it'd be 225. Again, the bottom out of -1 would happen between these two values, which would be 315. Okay, so if you were to plot the graph between 0 and 360, it should look like this, but then you should have another completed wave. So there's actually 2 waves between 0 and 360. Now, if we're talking about the amplitude, the height of the wave from the middle, if you like, that's just 1 still. But the period, which is the 1 full cycle of the graph basically, that's now 180 degrees. It's no longer 360 because we've got 2 waves in 360, so the period is just 180 degrees. Okay, so here's a kind of mix-up of different things. I've put the sine wave, sine 2x, and sine 3x all on the same graph, just so as you can see what's happening. So the normal sine wave starts at 0, goes through 180 and finishes at 360. If you've got a sine 2x, we just explored, that's a blue graph, it finishes at 180 for one wave, and then it will continue to 360 for the second wave. If you've got sine 3x, then if you look how many waves we've got 1, 2, 3 and 360. So this number here is really telling us how many waves we've got in 360 degrees. And you can also use it to find the period. If you take 360 and divide it by 2, you'll get when one wave finishes here, which is 180. If you take 360 and divide it by 3 here, you'll get when one wave finishes. Now that would be 120 degrees there.